Okay, this video is going to look at combustion reactions, just simple alkane combustion reactions. Another word for combustion is burning, and obviously it's with a fuel reacting with oxygen. So we have complete combustion when there is enough oxygen for all of the carbon and hydrogen in the fuel to react to produce carbon dioxide and water. When this happens, the maximum amount of energy is released for that fuel. Incomplete combustion is when there isn't enough oxygen to react with all of the carbon present. So instead of carbon dioxide being produced, pure carbon could just be produced. So ash, the black stuff that comes when you're burning a candle or something and you don't have enough oxygen, or carbon monoxide could be produced, which is very dangerous. Okay, so we're looking at just alkanes in this video. In particular, the simplest ones where the balancing is the easiest. So odd number carbon alkanes, so methane, which has got 1, propane, which has got 3, pentane, which has got 5. This is the simplest sort of balancing. So your reaction is between the fuel and oxygen, and it's producing complete combustion, producing carbon dioxide and water. So if we write the formula for the fuel, the methane has 1 carbon, 4 hydrogens, oxygen, carbon dioxide and water. So I'll have the molecules drawn. So methane, 1 carbon, 4 hydrogens, oxygen double bonded to another oxygen, carbon dioxide, 2 double bonds, and water. So when we balance these equations, we need to make sure that the number of carbons, hydrogens and oxygens that we have on both sides is the same. So if we look, our methane has got 1 carbon and our carbon dioxide has got 1 carbon, so that's balanced already. But our methane has got 4 hydrogens and the water has got 2 hydrogens. So clearly when we break this methane molecule up with the oxygen, 2 of these hydrogens are going to get with the oxygen to make water, and the other 2 hydrogens are going to get with another oxygen to make another water molecule. So we need 2 water molecules. So we've balanced our carbons and hydrogens. If we look, we have the most number of oxygen over this side, so we'll count up how many we've got. So we've got 2, another 2, we've got 4 oxygens altogether. So clearly we needed 4 oxygen atoms on this side. They come in pairs. Each molecule of oxygen has 2. So therefore we need 2 molecules of oxygen. When we're doing the balancing, we need to put a number at the front of the molecule to show how many water molecules we needed. So we've got 2. So this means we have 2 of the whole water molecule. The same thing here, we've got 2 oxygens, so we have to say we've got 2 oxygens. Clearly you're not going to draw them all the time to work out how many numbers that you need to balance them. So I'll do the next example without the drawing. Okay, so complete combustion of methane. This is methane. Always, first thing that you do the carbons first, then do your hydrogens. So if we look, the carbons were balanced. We've got 4 hydrogens here. The water has 2 each, so we need 2 water. So 2 times 2 is 4. So once you've done the carbons and the hydrogens, then do the oxygen. So if we look on this side, we've got 1 carbon dioxide molecule. So each carbon dioxide molecule has 2, so 1 times 2. Plus on this side, each oxygen has 1, each water molecule has 1 oxygen. We've got 2 water molecules, so we've got 2 lots of 1. So 1 lot of 2, 2 plus 2 is 4. Another way of saying this is we've got 2 oxygens here and we've got 2 oxygens here, so we've got 4 oxygens altogether. Obviously this is fairly easy at the moment. So on this side, each oxygen molecule comes in pairs, so we need 4 oxygens over here. 4 divided by 2, because they come in pairs, means we need 2 pairs. Okay, so we'll do propane this time. Propane has 3 carbons and 8 hydrogens, so we have to do the carbons first. And this time they're not balanced, so we've got 3 carbons over here. So we will need, each carbon dioxide molecule has 1 carbon, so we will need 3 carbon dioxide molecules. So carbons and hydrogens first. We've got 8 hydrogens on this side. Each water molecule has 2 hydrogens, so we will need 4 water molecules. 4 times 2 is 8. So now we've got the most oxygens we will have. So we work out how many oxygens we have on this side. So we've got 3. Each carbon dioxide molecule has 2, so 3 times 2. And on this side, each water molecule has 1, so we've got 4 lots of 1. So 3 times 2 is 6, and 4 times 1 is 4, so 6 and 4 make 10. So another way of saying it is we have 6 oxygens on this side, 3 lots of 2, and we have 4 oxygens on this side, 4 lots of 1. So 6 and 4 make 10. So we have to separate these 10 into oxygen molecules. So 10 lots of 2, 10 divided by 2 is 5. So you need 5 water molecules. 5 oxygen, would you believe? Okay, so do pentane. You need to write the formula for pentane first, then write the formulas for the other product, the other reactant and the products, and then balance them. So pause this, do it, and then check. Okay, so hopefully you got 5 first, so you do the carbons first, 5. Your water molecules are in 2, so 6 lots of 2 is 12. So now you go 5 lots of 2 make 10, 6 lots of 1 make 6, 10 plus 6 is 16, 16 in pairs, 16 divided by 2 is 8.